Write it down, define it, and then from that point going forward, just work your way through the overall process. So we're going to start off, we're going to say stop kills all. And when I mean stop kills all, it just shuts everything down. And we're going to say we need to press start, green light, on for 10 seconds. After green light shuts off, blue light on for 5 seconds. We'll say process repeats till stop pressed. When we get to doing the PLCs, you've also, the timers, the counters, all of that is built into the actual PLC. And then that's what this is really laying the foundation for, understanding how to label all of your inputs and outputs in the PLC diagram as ladder logic. So I have my process on what I want to have done. Stop kills everything. Press start, green light on for 10 seconds. After the green light shuts off, the blue light on for 5 seconds. Process repeats till stop pressed. Now I got that. I'm going to do my inputs and outputs. Inputs, outputs. Okay, so for what you see here, what's going to be our inputs? The stop and the start, right? Stop, normally closed contacts. Start, normally open contacts. What about for our outputs? So we know we're going to have a green light. Very good. Green light, timer, and anything else?
Red light and timer.
We'll have, so let's add that over here. If nothing's on, nothing on, a red light on. Okay. So now, since we added that, we didn't add no inputs, right? That's just another output. So we have the green light, we have a timer, anything else? We're gonna have a blue light, yep. What else?
Another relay?
A relay, we don't even have one up here, right? And why do we need the control relay? For the memory circuit, very good. So we got a green light, a timer, control relay, a blue light. We know we just added the red light, right? Anything else? Do you look at it, take a second. We're not in a hurry, we're good. Take a gander at this section right here. Right?
Seems like maybe another relay.
You're going to need another relay. So that'll be timer 1. Oh, darn it. Well, now I guess you know what else you need, right?
Timer 2.
There you go. My bad. Control relay 2. Timer 2. Okay, great job. Now you've defined what the process is going to be. You figured out what inputs and outputs you're absolutely going to need. So now from here, it's time to go through and we got to start drawing our ladder. if you want in the shop, I got little dry erase boards and pens because it does work pretty nice. So you could draw it and you just modify the parts as you're going through until you got one broke down to the way you need it. So we take these inputs and outputs. We know that L1 always on the left. L2 always going to be on the right. Our rails go straight down and our runs go across. So since stop kills all, the way I look at it, like every fairy tale once upon a time, stop kills all, to me, beginning of the story. That way it makes it very, very user friendly. So we have our stop button. Normally close, check, got him. Now I have a start button, right? And what's the start button actually turning on?
The green light?
Green light is only the green
Timer.
light. And
Timer. Control relay.
all of them, right? So we know that the start button is going to come over. That's going to fire up your control relay 1. We also have timer 1, and this is a green light. So what's the purpose of the timer? What are you doing with that timer? And you can always look back to your instructions right here.
It's timing 10 seconds.
And then it's going to do what to the green light?
It's going to switch to the blue light.
So it's going to shut off and then start the blue, right? So since we know that, I'm just going to modify, right? We know that that is going to be my memory circuit, but we said, hey, that timer is going to shut off that light. So what do we need to do? Run it through the timers, normally closed contacts, T1, CR1. So now we look at it. When I press start, control relay comes on. That seals your memory. Those are all 3 in parallel. Those are all 3 going to be on at the exact same time. As soon as you fire that start button. If we stopped at this point, when the timer times out, it's going to disable your memory circuit. Everything's going to shut back off. Now, if you move the timing contacts up here, it's still going to shut back off, but if somebody was holding the start button down, it would just come back on again. So we can modify it, but this will fit this requirement right here. Push start, control relay, timer, green light, come on, and stay on for a set period of time. So I've got all of those parts taken care of. What is starting the blue light? The timer. Specifically, which timer? Or timer 1, right? Because timer 1 is disabling the memory, shuts that off, and then it's going to close the contacts. And when it closes the contacts, what do you want timer number 1 to activate?
Timer 2, blue light.
The blue light, timer 2, and the
Control relay.
control relay. I like to start with my control relay on top. It doesn't matter. They're all in parallel, right? Because they're all going to be on at the same time. So I'm going to draw it right over here. Fires control relay 2. Timer 2. And we have the blue light. To keep this on, you need to have what? If you want that blue light to stay on, what do you got to have? A memory circuit. Now, on my memory circuit, do I just need an open set of contacts like that? And we write CR2? Or is there something else I also need in that branch?
From 0-1.
Timer 2, specifically, do you want open contacts or closed contacts? Closed, right? Because see, you're doing the same process over up here.
That'll be on a resting state right there?
All the symbols are always drawn in the resting state. So then this would be your timer 2. That goes right into that. What does everyone think about how this portion right here looks and how this portion looks? Same, right? No more, no less. But it's just putting all of your pieces in the right spot to make sure that it's going to be a successful installation. If we did it this way, can someone tell me what's going to happen? Run me the whole process through, if you would. Or how about we do it together? Press start, fires the coil, seals the memory. Because these are all on at the same time because they're in parallel, the timer's timing. As soon as timer 1 hits its set point, that opens. When that opens, that shuts off. The open closes. That turns on. That seals the memory. Timer's timing, blue light's on, and control relay 2's on. But is that going to keep my process? Because it says right here, process repeats till stop is pressed. Is that going to repeat the process for me indefinitely until I press stop?
No.
Huh?
No.
No, why?
There's no memory seal.
You got your memory to keep it on, but what do you need to restart the process?
Another start.
Another start. So what's going to really be starting the green light? With what you got drawn here. Look at the similarities.
Oh, the timer 2.
Bingo. So timer 2 is going to restart the process, right? So then because it's a start, stops are in series, starts are in parallel. You notice I left a little bit of a gap right here. Yep. That's going to be timer 2. So now, press start, control relay comes on, seals the memory, everything's on, everything's going, timer's timing. As soon as timer 1 hits its set point, opens the contacts up here, closes the contacts down here, turns on control relay 2, timer 2, the blue light. Control relay 2 kicks on, seals the memory, everything's latched on, timer's timing. As soon as timer 2 hits its set point of 5 seconds, that opens, that shuts off, that closes, that turns on, and it's going to go until your stop button's pressed. So when you want to add the red lights, you said if control relay 1 or control relay 2 is not on, I've got my red light on. And if you notice, I'm coming from L1, constant power, because if I moved it forward, anytime I would press stop, there would be no more red light, right? So, questions, thoughts, anything, any discussion you guys want to talk about on this example?
May you give us the diagram on how to wire it?
Of course I will. But I want to make sure I want to walk you through take a written set, figure out your parts, do your ladder, do the wiring. I want to get you from point A all the way to the end.
That's a good.
And then we'll draw up all of our parts and we'll keep everything, try to keep it all matching.
Why do we need 2 relays?
Because you have 2 different outputs that you're going to be timing on. So because your light doesn't have any memory circuit or anything like that, it's just going to be on while the button would be pushed. So to keep it on, you need that memory circuit to keep that coil energized.
So each light needs its own memory?
You're going to need, something to keep that process going. Same thing for your timer, because you're using the memory circuit to keep the timer on and your light on both of them. So that's why it's so important when we do this, like you know how to do that memory circuit, a stop start with the memory circuit. That's the number one we got to have mastered perfectly. Once you move past that, it doesn't, in my opinion, you're not really getting more complicated. You're just adding a couple extra parts. Some people, well, you're adding parts, so it's more complicated. Is it really? I mean, you're just opening contacts, closing contacts based upon whatever process it is you want to have. And wherever you guys go out into the industry, you're all going to be working probably with different types of equipment. But the overall theory behind it and interpreting this will definitely get you across the board and being able to break it down to figure out, because when you go to the plant, you're going to be troubleshooting. You know, the plant's probably had that piece of equipment in there for 10 years. You just got hired, we got to keep it going. You may not have the access to any of the ladder diagrams or anything. So for me, my biggest asset was my production worker. He runs that, or she runs that machine day in and day out, 8, 10, 12 hours a day. They know every step, they should know, every step of that process from start to finish. So when they call me when something's not working, I'm going to be trying to get information out of them. What starts it? What stops it? And if I know what starts it and what stops it, and I know how to use a meter, I can go through and figure out what's not working. The cool thing is, as you're moving to PLCs, this is all done internally. You have to draw it into the program, but your timer is not going to fault out in the PLC. The timers, those electromechanical timers we have next door, they're still out there in industry, and just basic stuff that's, you're not, having 100 inputs and outputs, just little stuff. Like we had stackers, so it would stack all the milk crates. That's where we had them in a little enclosure. The bulk of the equipment pieces you have, those things got, some of them have hundreds of inputs and outputs, depending on the size of the machine. But it's just adding a rung here and a rung here. And it just builds through the process. No matter what, something stops it, something's going to start it. So,
Mario, would these be on delay timers?
on delay for this one.
Yeah.
Because, and you got to remember, on delay timers start timing as soon as it gets the signal. Off delay start timing as soon as the external control switch gets opened up. And then you have some relays and timers have instantaneous contacts, and some of them are time delayed. So that's why it's good to look at your Uglies book on 126 and 27. And there is lots and lots of symbols. My old Nacer books, pages of symbols. Familiarize with all of the common symbols, because it just makes you're in my opinion, it makes your job a lot easier if you know what the symbols are. Because if you're looking at something, you're like, oh dang, what does this represent? What does this represent? It's going to take you a lot longer to interpret them too. So just get comfortable with them. You don't have to know all of them. Just know the common ones. And then over time, as you do it longer and longer, you'll start to memorize more and more of them. So if we're going to draw our parts up and go with all of our connections, we have our stop button. So we have our L1. We have our stop. We have our start. T1. control relay 1, and we'll have our green light, put it right here. And remember, you're going to have hot and neutral, ungrounded and grounded conductor. So this one will be our green. L2. Down here, T2, CR2, blue, hot and neutral, and I'm going to put my red light right here. Okay? So I'm going to start at the beginning. I'm going to do the red light last because that's the easiest one, not going to be nearly as much to do. As you're starting out, an easy way to help you take a ladder logic and to develop your wiring, and while we're using these bases, because remember, the bases change configurations. A lot of them that we practice on look like this. But I've shown you how to read the schematic. So all you're doing is making sure you're going to the right spot. So if I have a ladder, what I like to do initially at the onset of it is draw in here where I'm going to terminate all of my extra wires. So if this is my T1, because I'm going to start with my first process, I'm going to say that's number 1, that's number 4. Here's T1, 1, 3. Here's T2, 1, 4. Here's T2, 1, 3. Control relay 1, 1, 3. Control relay 2, terminals 1, 3. And down here, when I do these, I'm going to make this 8, 5, 8, 5. So now when I look at this, to me, there's not even a thought process, because you do wire by wire and you've identified each of the terminals. When I do it my way, always use the first screw as the common point on whatever set of contacts I'm going to be using. So if you're going to be doing it with 1 and 3 for the normally closed open, that could have been, when you're doing it, 8 and 6, right? Because that's a normally open set of contacts. So being able to read that diagram on the back of your relay or timer is extremely important, because you're going to have to read all of the different equipment you're going to be using. So to match this wiring up, power into my stop, number 1. L1 into my stop, number 1. Out of my stop into my start, number 2. Out of my stop into my start, number 2. The end of my start, notice it hits the 1 and the 4, or the 1 on each of the relays. Timer 2, number 1. Timer 2, number 1. Timer 1, number 1. Timer 1. So basically I know I'm going to have to come from here, the end of my start, to the end of T1, number 1. That's going to be my wire number 3. End of my start to the T1, number 1, number 3. So the end of the T11 is also the end of T2 number 1, number 4. T1 number 1, T2 number 1, wire 4. You've already got T11 right here, and see how it's T11 right here? you've already got this wire here because it's right here. It's the same thing, because that's the closed set, 1 and 4. That's the open set, 1 and 3. You don't need to take another wire to one. There's a wire already over there. So now that I've got that part of it set up, because I'm not duplicating all of these ones going down, now I start on this side of everything. So the out of my start fires my control relay, wire number 5. Out of my start, and when I make this little hop, it's just a hop over. So that's wire number 5. I'm going to go out of T1 number 4 going into CR1 number 1. That's going to be wire 6. So T1 number 4 into CR1 number 1, wire 6. Perfect. Now I got that one in. Now I'm going to take coil from the control relay to coil for my timer. Number 7. Coil from my control relay to coil from my timer. Number 7. Coil of my timer to my green light. Number 8. Coil, oh boy, that's going to be hard to get to. Coil of my timer to my green light. Number 8. And finally, I need to seal my memory right here. So that would be number 9. Right here, coil my green light, seal my memory. Number 9. I've got everything done except this. I'm going to do it in steps so you can kind of go through that process. So now we say we've already done T1 number 1. The number 3 fires control relay 2. So T1 terminal 3 fires control relay 2. Oh boy, it's going to start getting messy. And that's wire number 10. It's wire 10. Coil of CR2, coil of timer. Number 11.
Another color?
Huh?
Can you just do another color?
I was going to do this one with the black, because that's going to be the constant power that's constant power.
The red one doesn't work?
We could try that. Okay. Alright, now I have control relay 2 to timer 2, number 11. Control relay 2, timer 2, wire 11. I'll draw this one here. I'll turn this one to red. How's that? Timer 2 coil to blue light, number 12. Timer 2 coil, blue light. Number 12. Now I'm going to go back to my memory. So T2 number 4 goes into CR2's number 1. And that's going to be wire 13. So T2 number 4 to the CR2 number 1, and that's going to be wire number 13. Got to seal my memory right here. So I'm going to take my, you can take it from blue light to the memory seal, going to be number 14. So blue light to memory seal, wire number 14. So I've got that section, so I'm just looking, okay, that's going, that seals, that's through, perfect. What's starting the process again? Now I'll go to my black pen, right here. Timer 2, number 3, and I'm gonna run it right back to my start button. That will be wire number 15. So T2 number 3, right back to my start button, number 15. So now we got that's tied together, so it'll restart the process. I've got wires or conductors between all of those points. Everything looks good. Now I'm down to just my red light. L1 power through CR1 through CR2 to get up to your red light. L1 power. I'm going to change this, make this better. I just flipped them. It don't matter because they're in series and I don't want it to go everywhere. In to the 8, out of the 5. And that's going to be 16. From the 5 to the 8 would be number 17. From the 5 to the 8 would be wire number 17. And from my 5 to my red light would be number 18. 5 to my red light's hot, and that would be number 18. For all of our neutrals, I'm just going to draw a star. So that way you know where all of your neutral wires are going to go. Neutral, 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 neutral. That way I don't add even more wires than we would possibly need. But as you come over here and look at it, you've hit every spot. Into stop, out of stop, into start, the end of the start, the end of timer 1, and end of timer 2. Goes out of timer 1 into the memory circuit for control relay 1. So when I push start, fires the coil, fires the timer, fires the green light, seals the memory. When it times out, T1 opens up, that closes, turns on CR2, fires T2, fires the blue light, seals the memory. When this opens up, that closes, T2 refires it just like a start button, and the process stays on and repeats until you push the stop button. And the stop button has no effect on your red light because it's coming from your ungrounded conductor to energize all of those parts. I know it's a little bit congested, so if you want to take a picture of it, or if you want to ask questions before, because we're recording it right now, we can post that up there. Or any questions you have. My main concern or main goal is to make sure everyone feels good with it. And the big thing, we started off what the process was. We defined what's going to happen. We defined what inputs and outputs we need. Then we developed our ladder. And then we came over here and made up our wiring diagram. So we did it in multiple steps. We didn't go out of order. I mean, yeah, I did change these, but I didn't want to try to go in one and make a huge loop to get back to where I put the light. Because they're in series, it don't make a difference, right? Because if this one's on, it's open, no red light. This one's open or energized, no red light. And you're just going to be flip-flopping between the two. So any questions, thoughts, discussions?
When timer 1 normally open, is there any wire connected on number 1?
At this one, Of this part?
What do you want?
This
Yeah.
one. See, that timer 1 is that timer 1. That's the same exact. So see how I wrote the 1 and the 4? That's gonna be the 1 and the 3. That's the exact same point.
One's open, one's closed.
Right.
Which
So
one's
I need
16?
the close set to disable the memory, and I need the open set to start the next process. What you'll see done sometimes, you'll see a T1-1 or a -2 if you're going to use both sides of the timer. That way, if this is T1-1 set, that would be 1 and 4. If that was T1-2, then I would make that 8 and 6. If I was going to split those up, because see, I only use one side of my timer. I could have split it more, but it wasn't necessary to achieve my desired operation. But you could possibly see it drawn like that to separate it. As long as because I'm using the same set, I did not denote the additional set of contacts.
Why
Yes,
would you use a second set?
what can I do with the second set? Perhaps you're going to disable some other motor starter further down the line, or something else. But you could use that for, it's going to activate, everything's going to be based on the same time because it's going to come on. So the contacts will shift at the same point, but you could further break it down a little bit easier so that if you wanted to wire it up, you wouldn't use 1 and 4, then you would also use this as 8 and 6 if you wanted to split it up. All of your relays, all of your timers, all of those are going to have a maximum ampacity. Maybe if, with whatever outputs you had, using that one set of contacts would have been over the permissible current. Then I could use maybe the coils for one side and the lights on the opposite side, or something to split that energy.
Is that 16 right there? That the bottom?
Yep. There you go. I forgot to write 16. Sorry about that.
No, you're fine.
So any other thoughts, questions? Everyone feels pretty good? If you have more, you can always ask me too. Because like I said, I'm here to serve you guys. That's what I'm here for, to help you get more proficient. And if you guys want, what we could do is maybe do one of these in the morning time as like a warm up for our class. And then we got like 30 days left in the program this semester. So we could do one in the morning and then go back to the book, because your guys' test scores in the book are phenomenal. So if that would help everyone in here, is that what you guys would like to do it this way?
I
Do-
think so, yeah.
Okay, so then my request then for you guys, come up with the process that you want, and then we'll pick somebody's process up.